Hello everyone, and thank you for tuning in to this video. Today we're going to be working on a problem on Lewis structures and the importance of formal charge. So this question is asking us to draw the Lewis structure of the following molecules and which compound has the highest carbon-carbon bond strength. So we're given here 3 molecules to work with: CH3, CH3, CH2, CH2, and CH. So I really encourage you all to try to pause this video and to try and draw these Lewis structures out yourselves. It'll be good practice, and come back so we can work this problem together. So the first problem here, or the first one we have, is A, CH3, so you have 2 carbons with 3 hydrogens attached to each carbon, and we have this Lewis structure. So what I look at to find or to make sure that this is the right Lewis structure is to look at the formal charge of the molecule. So to find the formal charge, I use this formula: valence electrons minus the number of lines minus the number of dots. And this is, for example, if we're looking for the formal charge of carbon. So let's do that now. The formal charge of carbon here, the number of valence electrons of carbon. If you look at our periodic table, the valence electron for carbon right here is 4. So valence electrons 4 minus the number of lines it's connected to, so 1, 2, 3, 4, minus it's the number of dots, which is the lone pairs, so it doesn't have any, making it 0. So do the math. The formal charge for carbon, for this carbon, is 0. So we'll move on to the next carbon here. Same thing, right? Because it has 4 lines it's connected to, 4 valence electrons, and 0 lone pairs. So it will have a formal charge of 0. And 0 is the best that we can get for formal charge. The further you are from 0, the more unstable the molecule will be. So moving on to B, we know that this is a good Lewis structure to have for A. Okay? So B, we have CH2. We have carbon, 2 carbons, and 2 hydrogens attached to both carbons. So to make sure that the carbon has its full octet, you can do 2 things. You can have lone pairs on the carbon like this, or have a double bond between the carbons like that. So this is where the formal charge comes into play, and it distinguishes which molecule is more stable. So for this one here, if you look at the formal charge of the carbons again, for this one, we would have 4 valence electrons minus the number of lines, which would be 3, minus the number of dots, which would be 1, 2. So the formal charge for that carbon that's in the box would be 4 minus 3, 1 minus 2 would be -1. And it would be the same thing for this carbon here. So the formal charge of the carbons would be -1. Whereas with this one here, the formal charge would be the valence electrons minus 1, 2, 3, 4. 4 lines minus the number of dots, 0 is 0. So you have this carbon on the right versus the one on the left. And formal charge will tell you which is more stable. And in this case, we would choose this one because it has the formal charge of 0. Moving on to C here, we're being asked CH. Okay, so you have 2 carbons and attached is 1 hydrogen on each carbon. So to fill up its octet, you will either have this versus, this is becoming a trend here. Formal charge. We erase this. And then one more, right? We would have C, triple bonded C with an H. So we have here single bonded carbons, double bonded carbons, and triple bonded carbons. So, like I said, you have to check the formal charge on each carbon here. Let's do this one. So the valence electron of carbon is 4 minus the number of lines, which is 2, minus the number of dots, 1, 2, 3, 4. So the formal charge would be -2 for the single bonded carbons. And it'll be the same for this one as well, -2. So next we'll be looking at the formal charge of the double bonded carbons. So here the formal charge is 4 minus the number of lines, which is 3, minus the number of dots, which is 2. Formal charge would be 4 minus 3 minus 2, 1, -1. And then right here, it'll be the same for this carbon as well. Finally, for our triple bonded carbon, look at this one here. It's going to be 4 minus the number of lines, which would be 4, minus the number of dots, which is 0. So you can see there's a trend going on here. The higher the number of bonds, the more stable it is, right? So in this case, in this molecule that we have, we're going to choose, this one as our most stable molecule, okay? And now, bringing it all together, here, we're being asked which compound has the highest carbon-carbon bond strength. So now that we have our molecules written out, A being a single bonded carbon with single bonds, 3 single bonds to H's here. B would be the double bonded carbon with 2 H's attached to each. And then for C here, we have a triple bonded carbon with 1 hydrogen on each carbon. Okay, so now to figure out the highest carbon-carbon bond strength, you have to look at the bonds. And as some of you may know from lecture, the higher the bonds between like between, for example, carbon, here, the higher the bond strength. So in this case, the highest carbon-carbon bond strength would be C. And that makes sense because it becomes more stable here. And as you can see from the formal charge, the higher the bond strength, the higher the bonds between carbons, the higher the bond strength. I hope that helped in Lewis structures and formal charge connecting to the bond strength of a molecule. Thank you.